welcome to this tutorial for Gateways 2022, deploying HTC workload gateways on the Open Science Pool. So my name is Christina Koch. I'm based at the University of Wisconsin-Madison at the Center for High-Throughput Computing, where I do a combination of local campus support for the campus computing resources we run, and I also contribute to various OSG services as a facilitator. And so that's kind of my capacity here today. And then I'll turn things over to my co-presenter, Marlon, to introduce himself.
And hi, everybody. I'm Marlon Pierce. I know several of you, not all of you. So I'm director of the Cyber Infrastructure Integration Research Center at Indiana University. So I'll be giving the second half of the tutorial, which will focus more on science gateways and how they can integrate with the OSG and the Open Science Pool.
All right. So let's dive right in. So first, this is the objective we put in our proposal for this tutorial. After completing this tutorial, participants will have a basic understanding of distributed high-throughput computing, available OSPool capacity and tooling, and how they can use an Apache Aryavata web environment to leverage HTC capacity in the form of the OSPool. I'm going to do a simplified version of this in a minute, but first, I'd like everyone in the chat, if you can, to just either choose one of my pre-written options or just type a little note. What's kind of your goal or interest in this tutorial? Do you have a specific, like, I'm ready to make a gateway for this community? Or are you like, I want to know more about the OSPool? Are you curious about the part that Marlon will be presenting on, the kind of Apache Aryavata piece, or something else? It would be good to kind of get a feel. It's not really going to change what we present about, but I think we want to make sure if there's specific interest or questions that we make space for that. Okay, so lots of interest about the OSPool and what it's about. That's good because we are going to cover that today. Okay, so far a lot of interest kind of about the OSPool and other OSG services. I will mention some of the material we're using today comes from a webinar we gave like a month ago that talked again a little bit about OSG services and gateways. So if you'd like a different spin on things, that's recording is available. It was done through the Black Hole Peery webinar series, and it's online. So, okay, Serena is here for all of them, so that's great. So with that, the way I've kind of approached this tutorial then is that supposing our goal is that we want to kind of understand science gateways that might use the Open Science Pool. So a more succinct version of that official objective from the first slide I wrote out as we're going to introduce a science gateway that runs HTC workloads on the Open Science Pool or potentially on other high throughput computing capacity. And by the end of this tutorial, you won't have detailed instructions for how to go through that process, but you'll hopefully have a sense of what the major steps are, which I've outlined here, and which will kind of structure the flow of this tutorial, and you'll know where to go for more information for any specific step of this process. So these are the kind of pieces we're going to go through. So we're going to start with this first one, just kind of setting the stage, like, why are we doing this? So I moved this to the beginning because I think it really is important to think about, if we're thinking about gateways, like, why do we want to make a science gateway for people? Why do we want to have this sort of web interface that enables some sort of computational work? And so we're assuming in this example that there's a research community out there that has significant computing needs that is beyond what they can currently do. And that might be because of where they're located or the kind of where the community is at in its computing experience. But so here's our community in need. And we're here as representatives of, like, I am at least, of the Open Science Pool and OSG services. So I'm most interested in talking about today research communities who have big computational problems that can be expressed as what we call a high throughput computing workload. Okay, so what does that mean? OSG services center this model of distributed high throughput computing. We think of this as a workflow expressed as potentially tens, hundreds, or millions of discrete self-contained tasks, which are going to turn into jobs, where each individual task is runnable on one computer. So some classic examples are parameter sweeps and analyzing a bunch of separate data files. There's a lot of common research problems that can be attacked this way. And so in later parts of the presentation, we'll really focus in on the tools that we need to enable this kind of work. And OSG services, kind of separately, the computing capacity we provide is distributed. Both physically, it's all over the US and the world, and it's managed by different people. So it's like, in some ways, administratively distributed. And so that has to be, as we progress, you'll see that this factors into some of the tools we use and how we approach these problems. So we want to help a research community. And we're kind of focusing on research communities whose computational problem can be expressed in this many tasks kind of way. If anyone has a community in mind that they know, like, this kind of describes the kind of work they do, please either pipe up and share what it is or drop it in the chat before we move on. So, yeah. Does anyone know of a research community with this kind of computational problem?
I was going to type into the chat, but I'll pipe up. I work on a spatial ecology gateway, and these are ecologists who are tracking animal movements through their sensors. And so we're expecting a lot of data to come in, and they're going to want to run like home ranges and other computational tasks on those data. And so we eventually will want to probably submit to a supercomputer of some sort or high throughput computing resource.
Cool. Yeah. So they need to kind of identify different home ranges or results from the data sets that are available. Yeah. Anyone else? Any examples that you've worked with that this makes you think of? Okay, so Adam has put in the chat running machine learning jobs on GIS imaging. So yeah, I think a lot of image processing you can think of as a high throughput task if the images or data sets are all being processed separately. That's a good example. So if this all still sounds a little vague to you, that's okay, because we're going to use a specific science example today in some of our demonstrations and what we're talking about. So the example we're using is a computing problem from the Event Horizon Telescope project, which was in the news pretty recently about their cool black hole imaging success. So they run a lot of different computational workflows Don't ask me too many details about these because I'm not the black hole expert. I got these slides from Chi-Kwon Chen, who's a collaborator who's been using the OSPool. But we'll hopefully give enough context to understand what we're talking about. So today we'll be focusing on this first bullet point where they're doing image simulations with this tool called OSPool. And so it's basically you put in sort of different parameters, and what comes out is this sort of like moving image of what the black hole like looks like and its shape and rotation and all these different things. Again, I don't know the details of the science, but this is the general idea of like putting together images, parameters, running a simulator to get an image. And so this turns out to be a real classic high throughput problem, because there's a variety of source images that they want to use as inputs. And they have, as you can see here, these different parameters reflecting, I think there's like a upper threshold, there's like a theta of something, and different values. And you can see how as they test these different values, the number of simulations grows and grows. These are all separate, but they want to run a lot of them with all these different combinations of inputs. And you can see that as the inputs vary, the outputs are significantly different. So you want to explore this whole space. So this is kind of the sample problem we'll be using today, this idea of running this special OSPool image generator on a bunch of different parameter combinations. That's the science problem. That's the motivator. And we want to be able to support what's happening for this particular project. It's also kind of mesmerizing, the little swirly black hole images. Okay, so no, let me go forward. There we go. So for EHT, we've already, they've already kind of gotten going on the open science pool, and they've really been able to get a lot of computing out of it, to the point where this kind of burst that happened last fall, Farrell kind of tweeted mysteriously about what was going on, because that's when they were doing a lot of processing, preparing for the big image that was released this year. But really the goal is, can we make the scale of computing that we're going to kind of show you today, that was used by the EHT project, accessible to more people? So if there are more projects or communities like EHT that have this big high throughput like computing problem, can we support them and help them? So that's what we're going to talk about for the rest of this tutorial after that little intro. But I think it's important to set the stage of like, this is why we're going to start digging through the weeds of like services and how things work, and web stacks and all the technical details, which can get really detailed. That there's a lot of things to think about. The reason to push through that is to be able to provide this kind of transformative computing capacity to researchers and their projects. So there's the rah-rah motivational example of specifically of EHT, but if you have another kind of community in mind, think about how what we show today would apply to your situation. And so what I'm going to do next is kind of go through an overview of OSG services that are available to support these high throughput computing workloads. We'll do a little demo hands-on, and then we'll take a short break. And then after that, we'll go into this last item in our topic list, which is adding, once we have sort of something running on the open science pool, what does it look like to add the gateway on top of it to provide this nice interface, and the kinds of problems that solves in terms of making things accessible. Okay, So what everyone's been waiting for, according to my opening question. Introduction to the Open Science Pool and other OSG services. So I stole some of these slides from my colleague, Brian Bockelman, who's another one of the kind of leads of the PATH project, which is one of the major funders of the OSG consortium. So the OSG consortium is, I wouldn't even say it's an organization. It's a consortium that operates a fabric of distributed high throughput computing services in support of the research community. We are mainly funded by this project called PATH, which Partnership to Advance Throughput Computing, I think is the full name. And then this IRIS HEP grant, which is related to the high energy physics community. Okay, so what are these mysterious services? So I'd say our two big kind of flagship services are the Open Science Compute Federation and the Open Science Data Federation. And these are not so much specific like resources as they are all the infrastructure and all the services that makes the computing and the data movement possible. So the Open Science Compute Federation is a bunch of services that integrates clusters into these sort of virtual resource pools, which is what most people think of when they hear the term OSG. They think of these collections of computing resources that have come from potentially different physical and administrative locations and sort of been integrated into a single virtual pool resource that can be used to execute computing. And then kind of alongside that, we've developing Open Science Data Federation, which is a service for moving and caching data around the many locations where the Compute Federation operates so that data is more available across different computing resources. So there's data origins where people can upload their data, and then there's sort of a cache system where it gets replicated around the country. So those are kind of the big picture services. OSG Connect is a specific access point, what you might think of as a login node, that's operated by the OSG consortium. And we'll talk more about access points in general in a minute, and OSG Connect as a access point that we run that almost anybody can get an account on and use. And the OSG Connect as an access point provides access to a specific pool that's part of the Compute Federation called the Open Science Pool. So this consists of computing capacity sort of donated or shared by a bunch of different universities, national labs, other organizations, that's made available for running high throughput computing workloads. And you access it through OSG Connect. So I feel like this is all words, and hopefully, especially when we get to the demos, some of this language and the terms we're using will become a little more clear what we mean. So this is a really big network. The Open Science Compute Federation and Open Science Data Federation include computing and data resources from all these little stars across the US. There's also some international contributors. So it's a lot of people. It's a really cool, I want to say group effort to try something a little bit different in supporting researchers in science. So, okay. So that's kind of like the big picture. The OSG consortium operates this fabric of services that provide compute capacity and data capacity, and we have some specific pools of resources and access to them you can use. So what does this mean for our gateway aspirations? How can these tools help us take this big computational problem and run it? So this is the quick preliminary slide. The HTCondor software suite supports or integrates with most OSG services. So that's, you're going to see it. I'm going to kind of talk about things thematically. We're running through almost all the services that I'm about to describe, the different like features that you can use to run or support your high throughput workload are managed, part of, integrate with the HTCondor software suite. So this is, you can't avoid it, is what I'm saying. This is really the central tool that we use for that has a lot of the features we need to make this high throughput computing workload execution possible. So you could think of Condor as like a scheduler in the same vein as like Slurm or PBS or SunGrid Engine, but it really does a lot more, partially because it's been continually designed to support distributed high throughput computing. And so as we go along, you'll see that it also handles file management, user management, and integration with different resource providers. So, okay. But yeah, let's talk about some of these services in more detail, what we actually mean and what it means for a gateway. So I mentioned that OSG Connect is a kind of OSG operated access point. Again, if you've worked on a cluster, think login node or head node, but like more functionality. It's the general tool provided by Condor, the access point setup, is a service to place and manage workloads and files. It manages the jobs through Condor. It moves inputs and outputs through Condor's file transfer mechanisms, more on that later. It can, and this is a fairly new feature, but one that I think a lot in this community will be interested in, you can connect to different resource pools from a single Condor access point. So you can submit your jobs and they can run in the OS pool, and you can use your Exceed allocation if you want. So there's, and submit jobs from the same place, but use different resources behind the scenes. So I think that's going to be super powerful and giving people a lot of flexibility, especially if they're handling different kinds of workloads. So what this means if you were setting up a gateway is that your gateway needs to connect to some kind of access point, because that is literally how you will access resources and kind of manage the computing side of things. I'll make sure I update these slides and that they're correct, because I don't even know if I have the right credit here, but the sample gateway you'll see later has an access point that the team at Indiana set up, and I think can be used by other gateways if need be. And you can also spin up your own everything from scratch if you want. There's a very good question in the chat. When should someone set up their own access point versus one that is available? I mean, I would almost always use one that someone else is running because it'll be less work. I think you should use your own if you want to have more control, if for security reasons, like, your university is like, you got to use something that you're managing yourself. So I think it'll really depend on the situation that people are in. But the sort of access point configuration and software is sort of a standard thing that anybody can set up and run as sort of the home for high throughput workloads. Questions about this before I move on to kind of fleshing out some of the details actually that came up in this slide?
I do have a quick question for Marlon. I'm curious, how long did it take you guys to set up this access point, and how many FTEs?
Fortunately, I didn't, or maybe fortunately for me, I didn't do that. So Rob Quick set that up. So he couldn't be here today, and I think that's a better question for Rob.
Okay.
Yeah.
I would say he had a lot of, so he used to be the deeply involved in the OSG half a decade ago, and so he knew a lot about how things should work, and also how to reach people to get some specific help. And it still was some work, but I would, yeah, so Christina may want to weigh in on that. But
I know, yeah, I think it's a great question, and it would be worth following up with Rob, and we can maybe try to share with everybody what his experience was. I want to say that we really got this going within like a month or two, because he was partially depending on student effort that was only available through the summer. This is, I think, the next of the services that we really want to make as first class supported as possible, so that it really becomes as turnkey as possible. But how far we are along on that road, I don't want to say until I've talked to the probably the Condor team and the OSG software team, and then have a better sense of the big picture.
Thank you.
Yeah. Okay, so there's this idea of an access point. So like a head node, but with a little bit more functionality. So one of the things, as I mentioned, it can provide access to different resources. So if you're using, so we run a specific access point called OSG Connect. Anybody in the US can get an account and use. And so it, by default, you submit jobs there. They run on the Open Science Pool. This is, again, this big amalgamation of resources from different institutions. There's two other resources that I know you can connect to from OSG Connect, but also probably any access point that's been set up in the correct way to access resources. So if you have an access allocation, again, you can submit jobs from this HTCondor access point, and they can go run on a, Stampede or Bridges or Anvil or what's the one at San Diego? Expanse, all these different resources. And then the Path project separately is also standing up kind of its own self-contained facility, a distributed high throughput computing system. It's only available to folks who are funded by the NSF or might be funded by the NSF. But if that's you and you're interested, talk to me after. So what this means for our gateways is there's already this pool of resources, the Open Science Pool, that gateways can use. If you have access allocations, you can use those. If you want to talk to us about the Path facility, you can. Basically, computing capacity should not be a limiting factor in setting up something like a gateway. Like, the computing is there. It's through the access point. It can all be integrated together. Don't let that stop you. Okay. So computing at scale, data at scale. So HTCondor, again, kind of as a scheduler on the access point, has a suite of file transfer plugins that can be used to get data from various sources. And this is important because, again, the system we're using is distributed. There's no shared file system. So individual gateway jobs will need to get their input data from somewhere and their output data back. There's ways to transfer directly to and from, like local storage on the access point. And so you can see on the right here, but data could be in a web server. Data could be in some data store with an S3 interface. And another one of the OSG services is this Open Science Data Federation with a bunch of data origins and caches that can be used to share and spread data around the Open Science Pool and other HTC systems. So there's some more tooling in order to support high throughput workflows, potentially from a gateway, across a wide variety of computing resources. Okay. I think this is my last. And so my last kind of set of features. So we've already talked about different aspects of Condor, this idea of the access point, the home of your workload, these data movement features, being able to access different computing resources. Beside all these things, Condor has really powerful features for submitting lots of jobs at once and organizing their inputs and outputs in a specific way, automating retries, different kinds of checkpointing support, integration with some workflow tools like Dagman and Pegasus, and it also has a Python API. Most people, like in our sort of in-house use, we just have people make submit files and do the command line kind of job submission, as a lot of clusters do, but there's also a Python interface where you can submit and manage jobs using Python scripts. And so if your community has this kind of high throughput problems, Condor has the ability to express them in a really succinct, simple way in terms of being able to submit lots of jobs. It has a ton of customization options so that even if the software you're using is a little weird or things like that, there's probably an option in the whole submit set of commands that can help you. And if it's appealing that instead of writing out submit files and submitting them, you want to do something comes in from a gateway and then it triggers a Python script that submits a job, that's totally possible on the access point. So that's kind of, and I think this is historically what Condor has been known for, is sort of this ability to manage these large workloads. And then finally, because we're using this distributed infrastructure, jobs are running on a bunch of different computers. We have I personally have a lot of experience in like making software portable in a lot of ways. I would say, especially if you're doing something like a production gateway, I would recommend using containers, which you can fortunately use all across the open science pool. And yeah, all the high throughput resources that you can access from an access point. So basically anything you can put in a container. We support both native Singularity, now the Aptainer version, or Docker images. So yeah, that's for a gateway. You have a container, you have full control over the environment used by gateway jobs. That's available to you. So I know that's kind of a laundry list of features and services. We will get to a demo in a minute where you can maybe see all of this a little more concretely, but I'd like to open it up now. What questions do people have about what's possible, a specific service, specific use cases?
Is open on demand could be considered a gateway?
That's a good question. So Adam's question is, would open on demand be considered a gateway?
I'll take that one, I guess.
Yeah.
I would say yes. There are different flavors of gateways, and sometimes people want to associate with the term and sometimes they don't. But I would say, speaking broadly, they are, and they'll actually be doing a tutorial later this week and for Gateways 2022. And I think they have, if you're at the conference in 2 weeks, they'll be there as well. So yeah. And I'll say a little bit more about what gateways are in general terms during my section.
Thanks.
So there's a question about, must Docker containers be converted to Singularity? Well. So Condor, native Condor, does have support for running Docker containers directly. The limiting factor tends to be what the actual compute nodes, whoever's running them, what they're willing to support. So for our local resources at UW-Madison, we have a high throughput system, and people can use Docker jobs because we're willing to let that happen. But on the OSG resources, the open science pool, I think there's been, I don't know if it was decreed from on high or if it kind of came up from the sites that were providing computing, that there was, I think, a reluctance to let people run Docker containers or have Docker enabled, or there could have been technical issues that I don't know about. But yeah, technically it's possible, but I think the way things are set up now on the Open Science Pool is we convert Docker containers to Singularity images to actually execute them. So yeah, Mona, go ahead.
I have a couple questions. One is, does HTCondor have a connection or connector to Globus? Because Globus is a large file transfer, and it sounds like HTCondor also does something similar.
Yeah.
So I'm trying to understand, does one use one or the other or both?
It's a good question. I don't think there's built-in, like a built-in file transfer plugin for Condor that integrates with Globus right now, where like, you'll see one of our plugins later, but basically you can have, like if you have an input file in S3, you can say S3:/ path to file, and then it will get pulled into the jobs execution environment from whatever S3. You can do the same thing with Google Drive or Box. But if the data is behind a Globus gateway, I don't think there's like a Globus : / where you can pull the data directly. Yeah, I'm fairly certain that's the case. We are working with some groups right now that are pulling data from a Globus interface. So we're having conversations internally about that right now, but I don't think any decisions have been made in terms of development or new features or how exactly we're going to support that use case.
Okay, thanks. And then my second question is, maybe you're going to cover this later, but can you talk a little bit about how accounting is managed using OSG? Like is it kind of like Exceed where you send a proposal, get an account?
Yeah, this is a great question. And I don't think I have it later in the presentation. So I'm glad you asked. So using the Open Science Pool from the OSG Connect access points, or just the OSPool in general, does not require an allocation. You just need an account on an access point connected to the OSPool, and then you can submit jobs, and we determine who runs when by using Condor's built-in fair share priority algorithm, which, you know, like most fair share algorithms, does some calculation based on like the amount of compute you've recently used compared to everybody else. So if you've dominated for the last week, your priority will be a little lower, so everyone else gets a chance, and vice versa. You can, if you're applying for allocations through Access, I think you can get like an allocation on the Open Science Pool, and we have a mechanism where we can like basically just, what that means is we boost your priority manually until you've exhausted your allocation, and then you would drop down to the normal level. That's my understanding of how it works. I would want to confirm for sure with Mats Ringe, who's our kind of local expert in how that works. The path facility, which I mentioned a couple slides back, that is more of like an access type setup where you apply for an allocation or apply for credits. It's not through Access right now, it's its own process. So that is more of like that kind of setup. And then Access obviously is, you apply and you get different allocations.
Okay, so if we do the first wave that you had said.
Yeah, the Open Science Pool.
Right, and so that's in essence free compute then available to, okay.
Yep.
Thank you.
Oh, another tough question. Is Stork still available for file transfer? I don't know, but I can find out during the break. Any other questions? about any of these services. Computing, data, workload. We are going to switch into demo mode. And so hopefully if that will raise other questions for folks about how things work. Okay. So moving through our topics, we've just gone through a list of different OSG services and Condor features and resources available to kind of support high throughput computing workloads being run from a gateway. So to kind of break things up, we're going to do a little bit of a hands-on. So folks can feel free to just watch or follow along for this first section. We're going to do just some basic HTCondor job submission. We'll do a basic example, and then I'll do a more involved iPoll example that I got from CK of the EHT project. But it's kind of up to you. If you already have an account on Open Science Pool access point like OSG Connect, you can log in there and download this quick start tutorial. If you don't have an account on some kind of OSG or Condor access point, and you want to follow along, I will, fingers crossed that this works. We'll be using this kind of new, it's a little bit of a prototype notebook submission. So this is not going to, it'll put you in a little Condor environment that won't actually give you access to the Open Science Pool, but is good for kind of practicing how these things work. Whoops. Okay, so I'm gonna, what am I gonna just do? Okay, can folks still see my slides? Yep, okay, great. So I'll pop this in the chat so it's a little easier to open for anybody who's interested. I'll reload. You do have to authenticate, and you can, I'm going to use GitHub, which I've already set up. But you can also, if your institution is part of CI Logon, you should be able to use your institutional affiliation. And if not, if this doesn't work, we're going to use, I'll have to use something else as a backup, but give everyone a minute to get connected if they want. Go ahead and we do know, just FYI, that Orchid does not work if you do this setup. Okay, maybe I'll have to use my UW-Madison credentials. Oh, hey, it worked. All right. I'm going to use the data science notebook. This is the one I've been using. But I think we're basically using the Condor functionality, and I think all of those should be available through any of the options you see on the server page there. And again, for those of you who have existing OSG Connect or other OSG access points, you feel free to log into your own local setup. Okay, so I'm gonna, you all don't have to do this. I'm just gonna make my prompt a little easier to read. Okay. So hopefully folks who want to follow along, we're able to connect either through that notebook link Mine opened a terminal automatically, but you should be able to launch a new terminal. If that didn't happen, and click on this little guy to make files go away. And so we're going to do this tutorial that introduces the very basics of how Condor works. And you can kind of see a lot of the things I was talking about in the previous section, actually how they work out in practice. So you should be able to run this tutorial quick start command. And then it should download a folder called tutorial quick start, which you can CD into. And then we can take a look at the files we have available. All right. So in this example, we have two shell scripts that represent what we actually want to run. So first, we're going to look at this guy, short.sh. Actually, let me put in the chat. Once you've logged in, you should be able to run this tutorial quick start command. If that doesn't work, these tutorials are actually on GitHub. So you can also just do a git clone if the tutorial command isn't working for some reason. So let me just pop that link in the chat as well, in case you need it. Okay. So first I'm going to look at this shell script. So I'll use the less screen reader. And so this is like your hello world, right? It's just printing out information. When did it start? Where is it running? What's the username? Where is it running? It's going to work hard for 20 seconds and then complete some science. But you want to think of this as this eventually is where we're going to want to put, the actual computational work we want to run. I'm going to show an example a bit later, which is a much more involved script that runs the iPoll imaging tool used by the dHT project. So this is what we want our job to execute. So to actually submit a job, we're going to use a submit file. And so I'm going to look at this tutorial01.submit. And you'll notice here that the executable is the name of the script we just looked at. So for those of you who are familiar with like Slurm, PBS, where the kind of submit options and the job commands are put into one file, that in Condor job submission, there's a separation between those two things. So you have a script, a standalone script or compiled program or executable that then gets referenced in the submit file, which contains all your kind of submit information. So besides that, a lot of these options should look familiar if you've used a scheduler before. Here's where we're going to save our standard output or standard error. We're going to request this many resources. These are teeny tiny requests because this is not a super intensive job. And then we're just going to submit one job. So change at the end. So again, I'll type Q to exit and I'll type Condor submit to submit jobs. So in it goes. And then I'll run Condor watch queue while we're waiting. Oh, that's interesting. Oh, there it goes. Okay, it's running. So while we're waiting for this to run, I'll look at the error. Oh, volume already exists. I can definitely message the developer of this tool over the break. The best I can offer at this point, if the notebook isn't working, is to try to log out and log in again. Okay, so this is going to run really quickly. It's just, and in this case, it's running on a little local worker node instance of HTCondor. In the Open Science Pool, it would go out and run on a resource elsewhere. So I'll do Control C to get out of this Condor watch queue example. And so what I should see is I have my new standard output, standard error files that were produced by this job. And if I look at short.output, that should have pretty much everything the job ran on today. So it was running on this little private node that I have in this directory. And then it prints out my little messages. So that's probably the most bare bones kind of submission there is. So now we're going to skip to tutorial 3 because it shows more of the features that I was talking about in the earlier part of the presentation. So for the next example, we're going to look at this other script, which I may just actually cat out now because that's simpler. So it has some of the same components as the first script. But you'll notice, okay, glad to hear things came up. You'll notice that this script, much more like a real science workflow, is going to have an input file. So it has an input argument. The argument is the name of a file. And so this is going to print it out, print that input to an output file, and then do the same little like sleep situation after printing the contents of the working directory. So kind of just layering in something a little more realistic. You might have arguments for the thing you're running. You might have an input file. We're going to go a little off script, and you can submit tutorial 3 just as it is. So I'll print that guy out, tutorial 3, submit. Starting here. And so you'll see similarities to the previous example. CPU's memory disk. Here in this example, so we're kind of building up some of the complexity. We're putting these standard output, standard error, and log files into a subfolder so that things are less cluttered. So we start to get into this idea of file organization. This script uses an input file and has an argument. So we have arguments that we're going to pass to the script. And we have an option to transfer the input file to where the job runs and to transfer the output back. I kind of want to do, well, we can run this as is and then we can make changes. One thing I am going to change in this tutorial 3.submit, you can use the file editor of your choice. Because I am running on this very small node, I'm going to change my disk request to like, I don't know, 100 megabytes or something. So as a side note, I think most people are familiar with requesting CPUs in memory when they run submit jobs to a shared system. Disk is a little more unusual. That's again, because it's a distributed system. Jobs are actually running on a scratch directory on the local disk of whatever node they're using. And so as good citizens, we want to request how much space we need so that we don't overwhelm the machine. It doesn't run out of disk space. It doesn't get over allocated, that kind of thing. Okay, so I'm going to make that change. And then at the end here, you see this Q10. This means Condor's going to submit 10 jobs. And those 10 jobs are going to essentially be identical, except for the files they produce, these error, output, and log files, are going to have unique names based on the job numbers that are auto-generated for those 10 jobs. And we'll see that in the output after we submit. So I'm going to save my changes. And again, run Condor submit. tutorial 03, submit. Now I have 10 jobs in the queue. So if I run Condor queue on its own, I can see, oh, I had jobs go on hold. What? Okay, we'll debug those in a minute. So there's my previous batch of jobs. I must have run these like this morning. Hard to say. Okay. I have my group of, you see how there's 10 jobs here. And they're each going to have a job ID of the form 10.0, 10.1, all the way to 10.9. And those are the numerical values that were being referenced by these cluster and process variables. So we should see our output files should say job 10.0.error, job 10.1.error, and so on. All right, so the batch I just submitted is done. If I run Condor queue again, they've disappeared. So they're complete. And so I'd expect to see my outputs in the log folder. So first, my current folder hasn't changed. And that's again, because the tutorial.submit file here opted to kind of organize those files into a subfolder. So if I run ls-l in the log folder, here they are, all my piles of output. And so you can see for each job, here's the numbers that got filled in for the file names. Yeah, here's everything, basically. The error files are empty, that's great. And we'll look at the last standard output file. And again, prints out that same information. Apparently, the input file is hello world. That was the contents. And then I printed out a copy of the working directory. Okay. So I'm gonna, in a minute, switch to a little bit more involved demo of an iPull example, just so you can kind of see what this looks like as a real fully fledged workflow, not kind of this very stilted hello world kind of thing. But do people have any questions about what's happening? What Condor is doing? Any of the submit file options? I'll bring out tutorial 03 again real quick so people can see. Yeah, Mona, go ahead.
I'm curious what happens if you've asked for either more CPU, more disk than is available, or you use more than, you say 100 megabyte and you use 600 megabyte or something.
Yeah. So it's a good question. If you use more than you request, we have on our access point, the OSG Connect access point, we have some enforcement set up that will put your jobs on hold. Speaking of, right, okay, that's a different reason. And so I'll maybe see if I can demonstrate that once I switch over to the other access point I'm using. If you request more than it's available, your job just won't start. And in fact, I changed the tutorial 03 submit file because I was having this problem earlier. So let's bump this up. Let's request 2 gigabytes of disk. I don't actually remember how much is on this. Okay. So I've requested more disk than I think is available. Let me do total disk on this. Yeah, so this little, the only worker node I have access to has 950 megabytes of space. And the job I just submitted, again, I re-edited the submit file, requested 2 gigabytes of disk. And you'll see if I keep running Condor Q, those jobs are still idle. And in fact, they're never going to start because they're requesting 2 gigabytes of disk. And from this little, sandbox Condor environment, the only resource they have available to doesn't even have a gigabyte of disk. And so they'll just wait. And this is why I tell people, if you, on any resource that's using Condor, if you submit something and it hasn't started within a few hours, you should talk to us so that we can help you figure out why, because it may be that you made an impossible request. People sometimes ask, why doesn't Condor tell you if you've made an impossible request? And it's partially because our resources keep changing. You might submit a job that requests, I don't know, 64 gigabytes of memory. And when you submit it, there's no resources in the OSPool with that much memory. But in an hour, there might be. And then your job could run. So it's a little subtle. But if you do your due diligence in requesting the resources you need, and things won't go over, then you should never be in a situation where you cause trouble.
Okay, thanks.
Yeah. Any other questions? I'll also just point out the log file, which I didn't highlight before, will give you a little record of how much you used of what you requested. In terms of, so I in the submit file requested, for the first round, I submitted 100 megabytes of disk and I used 2 kilobytes. And I requested 1 gigabyte of memory and I used 2 megabytes for this set of test jobs. So that information is available in this file and also in some of Condor's historical job accounting. So, other questions from folks? Give this a whirl.
Just out of curiosity, can we also see where the jobs were run?
Yes, so that is also actually in the log file. It's a great question. Where did the jobs run? It's in this line here, executing on host. If you're in this little sandbox directory, it's not very interesting because it's not actually running out in the open science pool. But we'll try to, in the next example, I'll kind of show some more interesting results there. It's a great question. Okay. So I'm going to move on to a slightly more advanced iPool example. It's based on this like real working set of tools from the EHT project. I'm going to use a little bit of a simplified version because they've built in a lot of like really wonderful like automated setup and tooling around submitting these iPool jobs. But I think it's a little easier to see how everything plays out in the Condor submit file if it's done a little bit more manually. So I'm going to go ahead and share my terminal. So I am now on one of the OSG Connect access points. So I've moved away from this like sandbox environment and I'm running, I'm going to be submitting jobs from kind of the full-fledged access point to the open science pool. And so I have my little folder with some of my example files that I'm going to walk through. So we'll start with, in this bin folder, I have a copy of the iPool program. And so what I want my jobs to do is basically this. Bin, I want them to run iPool, and I'm going to provide a parameter file. That's it. So each job, that's the problem I come to the open science pool with. And then as I, so now is where you have to start reverse engineering. So now thinking ahead, I'm like, I want to submit, say, 100 jobs. So I need 100 different parameter files. the way that this particular setup works, and those parameter files are going to have different options in them. There's a parameter called r_high, there's like an angle or theta parameter, and there's a row parameter. So I want that to be reflected in these parameter files. So in this example, we're going to see a wrapper script. So this is like the full-fledged version of like the little shell scripts we were just looking at, where there's like, it makes sure it has the right number of arguments. It sets the name of the IPOL program. It does a checksum to make sure it transferred properly. It takes in command line arguments, setting the name of the input file, and these three parameters that I mentioned, the r_high, the theta angle, and this row 0, blah, blah. And then this particular setup generates the parameter file from those arguments within the script. So that's what's happening here, filling in, you know, the different sections. And then all the way at the end, we actually just run our IPOL command. So here's a script that's been set up to take in different inputs and execute this IPOL program. Okay. So I could, if I wanted, run this script and put in the name of an input file, and then I can't remember what that is, something like this, you know, and that's like 4.26 e to like the -17 or something along these lines. So we've translated our very basic command into a script that can take in different inputs. That's kind of stage one of HTC-ifying this process. So now I want to take this. So the wrapper script is my job executable. That's what I want to run, a bunch of different inputs. And so now I'm going to put this into a submit file. So that's my executable. I'm going to have variables representing the different inputs that the script takes in. And so these refer to what's going to be unique for each job. More about that in a second. I'm going to transfer the bin directory, which has my IPOL program and some other tools. I'm also going to transfer my input file. So the input is both provided as an argument to the script, and it also needs to be transferred, the specific snapshot that's being processed. This should look familiar. Output error log going into a directory where they've been named by some of the different variables, again, those unique parameters that we're putting in. Then we have our requirements. This example is also using a singularity image as sort of the generic environment for IPOL to run in so that it's really consistent. You don't end up on machines that don't, where like you compiled on one operating system and it doesn't work on the other. And then this is really the magic thing at the end, is this is basically a for loop where we are setting all those input values that you saw up in this as variables up in this part of the submit file. So we're going to set the name of the input file, its checksum, a snapshot identifier, and then the three parameters we're varying are high, theta, and row from this mysterious file. Okay, what is this mysterious file? Yes, save my changes. So this is basically a CSV, but it's a list of all of my data, all of the combinations that I want to run for this workload. So I have my data file, the checksum, the identifier, and this is my r_high, theta, row 0 value. So I've taken one command, turned it into a script with arguments, and then I've put the script and its arguments into my submit file, and I'm now feeding into the submit file this list of all the different things I want to run. So how long is this file? So the file has 100 lines. So if I run Condor submit, I did check that this works, but you never know. Live demos, anything can go wrong. So I'm going to submit my submit file. There go my 100 jobs into the queue. And if I do, let's use Condor Watch queue. It's a little more fun. So here are the jobs I just submitted. They're idle. And as they start, I should see many of them start running at once, if all goes well. And then they'll go off and they'll each generate their little parameter file, execute it, and bring back the results, which will get mapped to an output folder in my current directory. So I kind of speed run went through that. I think the important thing is not the specific details, but just to kind of see how all of this can come together into a Condor job submission, incorporating, I kind of glossed over it, but the submit file is transferring data from our data origin, the one that we host at OSG Connect. That's part of the Open Science Data Federation. It's using a container to kind of keep the environment consistent. It's using Condor's features for submitting lots of jobs. There's some bespoke requirements in there. So like, we're using the different features we need to support this particular workflow. Oh, there they go. Yay. Okay. So now I have 28 jobs running. And if all goes well, they'll keep running for a little while and not immediately fail, which is what was happening this morning. And yeah, there they go. It's very satisfying to watch that click over. And so this is the kind of last example before the break, and then we'll switch over to once you have something like this running, how do you add the gateway component? This is kind of what's possible. This is what I went through the list of services. This is a little more, hopefully, concrete view of how it works. This is what's possible for research that is amenable to this kind of high throughput approach, either on the OSPool or on access allocations. And yeah, we'll talk about next steps at the end, but there's a lot of support to help you get here in terms of getting things running. So while we let jobs keep starting, I think these were all requesting 4 cores and a decent amount of memory. So this is not too bad in terms of startup. Questions about kind of any of the features I walked through, anything anybody wants to see again in a little more detail? I went too fast through it.
I noticed I think it was in the submit file, there was a cut command.
Mm-hmm.
And I was wondering if the input data was all in one file and you were cutting out different chunks, or are the input files already separated to make it easier to send out to multiple locations?
So which file had the cut command? This one?
No, I think it was
This guy? The wrapper
yeah.
script? Yeah, I don't know. Yeah, I think this is just extracting information about like a checksum, which
Okay.
there's other better ways to do this. But so I think your question is a good one though, in that part of setting up a high throughput workload like this is thinking about how you want to handle the different inputs to the different jobs you want to run. So I've seen people who like for example, would have generated all the parameter files in advance. And so then each job would have gotten 2 arguments, the like input data and the parameter file. What CK has done here for his setup is he's written the parameter file as part of the job. So he inputs all the parameters as arguments along with the name of the like input data. And then the job generates the parameter file, and then it executes the parameter file with the data information. So there's sometimes too many ways to do things. We do recommend that you don't send like a whole data set if you're only going to use a piece of it, that you either want to split files or, you know, isolate out the chunks of data you need, if possible, so that you basically, so you aren't moving data you don't need to across the system. But I wanted to, let's not do that. Just look at a log file really quickly. So here's a lot more information. So here's one of the jobs I just started. So you can see I submitted it, where I submitted it from, started transferring the input files, finished transferring the input files, and then the job started executing. So there's that kind of data stage in, it runs, and then there'll be a data stage out at the end once the job completes. And this one is running on Lancium, is the resource. Usually somewhere hidden in here is the actual server name. If there's a specific question you would have about like where something ran or what was going on, it's often helpful to talk to like the facilitation team, because we know a little more about the individual resources in a way that most people shouldn't have to know. Like it's only useful if it's you're troubleshooting. But yeah, that information is in the log file. Thank you. Okay, I have 78 jobs running. Very exciting.
I
Yeah.
do have a related question. So I guess it sounds like we don't have to specify what host we want to run our jobs on. Okay,
Nope.
but can we, if we think that we need a specific type of or a number?
Yeah, so you can specify, away we go again. So beyond kind of your standard memory, disk, CPUs, you can add bespoke requirements. So Condor, when it's running on all these different worker nodes, execution points, will advertise a bunch of different attributes that can be used for selection. So you very, very rarely will want to use the actual name of a server because you don't know if it's available. You may have to wait a long time. It can be limiting unless there's like some very specific, like, I don't know, you have to use this server for something because there's something that you can only access there. But usually you want to do things like these requests. If you want to use GPUs, you can request GPUs. And then these requirements, you can really add a lot of things. So this particular one is for instruction sets, actually, because I was getting instruction set issues on a specific set of hardware. And so then instead of blocking like specific nodes, I'd just be like, okay, I think my jobs are going to fail unless they run on a node that has AVX2 instruction sets. That happens to be one of the attributes that Condor advertises. And so I can use it in my requirements. So this is kind of an all general purpose mechanism for selecting nodes. Let's pick a node. Let's just take a look. So this is the absolute stack of information that Condor tracks about OSPool nodes. It varies a little bit sometimes across resources, but you've got architecture, version of Condor, CPU family. This probably translates to some sort of meaningful distinction between types of CPUs. Well, locally we have CPU model. Okay, then there's like a bunch of other project specific thingies. What else? Disk. There's also memory and CPUs. There's a lot of these guys. So this was the resource. It has AVX, but not has AVX2. So my jobs wouldn't run on this resource. I picked this one because that is where they were failing before. Yeah, I mean, there's a whole bunch of, once you get into the hases, this has GCC, has Java, has R, has rsync, has Singularity. Sometimes, so I put that I was using a Singularity container, and so there's something behind the scenes that auto populates my requirements with that I'll only run on machines that have this option so that they'll execute. Oh gosh, it's never ending. There's a lot of information here. So if you have very specific needs, there's a lot you can do in terms of these very specific requests. Oh, look, CHTC. So let's see this. So yeah, here's a server that has the AVX2. So my job could run here. And for it will depend a little bit on what's available. If the node has GPUs, then there's a bunch of additional attributes related to the GPU, like the CUDA capability, the memory on the GPU, and those are all things that you can use to select for different features. It's a great question. Okay. Other Condor, OSPool, OSG services questions? I'll just pop in the queue. Condor status is the command for looking at available compute resources. So Condor Q is for jobs. Condor status is for command. So right now in the OSPool, we have 24,000 slots, of which 21,000 are claimed. So a lot of computing going on. Yeah. Other questions? Thoughts? Okay, if not, I think we'll take our break now. And because this has been a lot of content and a lot of information. Hopefully everyone has kind of a sense of like what's possible. That's, I hope what people take away is like, what could we maybe do using the open science pool? What kind of workloads could we support? How could we scale? And so after the break, I will be turning things over to Marlon, and he will be going a little more into the gateway side of things. So once you have kind of a high throughput setup on something like the open science pool, what can it look like to add that additional layer of accessibility through a gateway, what it is and how it works. And there will also be, I think, a demo, and people can actually look at the gateway we're going to use. And it's going to be running the same kind of iPool jobs that I just demoed. So there'll be a point of contact.
So this section is going to be about integrating science gateways with OSG services and HTCondor. So goals for this section are basically understand the benefits of how science gateways and OSG could play well together at a high level. And then also the second goal is demonstrate some basic integration of an Apache Arvata-based science gateway with an OSG access point. So the format here is I'm going to have some slides, and they'll be wonderful and entertaining. If you make it through the slides, then we'll get to see some demos. And depending on how much time is left, we can potentially play around with the play around with the demo itself. But I'm going to show the demo. I'm not going to do intensive hands-on sections as we go. But if you want to get an account and check out some of the things that I demoed, then we can do that after the main presentation. All right. So what are science gateways? The Science Gateway is maybe a term of practice used mostly within the National Science Foundation in the US. You might hear them called science portals or virtual research environments and other things like that. The differences are probably not important. In general, a Science Gateway is a science-centric web-based user interface and the middleware underneath it that provides you access to cyber infrastructure resources like the OSG. They don't have to be web-based. You could have Jupyter front ends, or you could have Electron.js local clients or other things like that. Those are all also they can work, but basically what they're doing is giving you access through a nice user interface to multiple distributed computing resources, scientific software, data sets, things like that. So if you like, you can think of them as providing an X as a service for software, for data, and for computing. One thing I've really been convinced on over the last 5 or so years of being part of the Science Gateways Community Institute is seeing this in practice is the importance of not just good engineering and good open source software, but also designing for user experience, usability, and other things that target communities are going to want to do. Science gateways are often presented as things that democratize or simplify access to advanced resources, which is true. But they're also adding value to those things. So it's not just, so here's your web interface to simplify things so you don't have to figure out how to write a HTCondor submit script or a batch script, but also these things can do gateways can do things like support online collaboration and reuse and reproducible research results. And then the last thing they can do is they sit above, at least the way a lot of gateways are built is they sit above any particular type of resource or cyber infrastructure. And so they can federate and integrate these into one larger system that serves the needs of specific scientific communities. So let's take a few moments to walk through some benefits of science gateways and OSG working together. And in the second half of my presentation, I'll be showing some demos that I will hopefully you'll connect all these things, and the demos will illustrate all these things and put them into action. So the first thing, of course, is that you have user management. So an access point, you need to have access to the access point. So how do you manage all the users that want to use an access point, especially if the number of users in your community is going to be hundreds or maybe thousands of users in the case of some gateways. So instead of creating individual accounts for every user, you let the gateway manage the user accounts. So basically, as we'll say coming up in the next few slides, there's several things that kind of dovetail together, but the basic thing here is that these web interfaces are good for managing accounts, and they can also limit what people can, or put guardrails around what people can do with the access point. So related to that is federated authentication. So if you're running an access point and you put a gateway in front of it, then you could take advantage of all kinds of support in the web world for federated authentication. So in Christina's demo, you saw CI Logon, which is a great resource for an online service for providing access to all kinds of identity providers, mostly academic, but also non-commercial identity providers. And of course, there's a well-known standard called OpenID Connect that is used here. So this federated authentication also is useful because it allows you to piggyback on your university's two-factor authentication, for example. So you don't have to worry about how not just managing the accounts, but also how people are going to be authenticating to your access point. So basically, you handle that at the gateway layer and let the gateway talk to the access point. And then another benefit for combining gateways with OSG is that you can put guardrails around what users are doing. So in some cases, of course, you have power users and they want the full access of the access point. And that's fine. And usually those are people who are going to be setting up things for other people. Their immediate colleagues or maybe their entire community. With the gateway interface, though, you can limit and say, this is specifically what you're going to be able to do on this environment. You're going to be able to run this software. You're going to be able to use this amount of resources. If there are other policies that need to be implemented, gateways can implement those without requiring the user to do these things, such as, you got to get your data off the machine. Don't keep your many terabytes of data sitting around on of your personal data sitting around on the access point, but get it moved off. So so instead of just telling people these things or implementing scripts that maybe enforce these things, with a gateway, you can do these things a little bit more naturally. The other side of the coin here, and looking at this more from the user point of view, as opposed to the gateway or the access point provider point of view, is that gateways, they're hiding a lot of the complexity. So some people want and need the complexity, but there are many other users who do not. So gateways can provide default settings and default values for the software that you're running. And also they can provide a more a broader user environment than you're going to get with the command line, of course. So where you can integrate documentation, video tutorials, and other aids to help users quickly become productive. So when users use the gateway, in our terminology, in our group, we call those things computational experiments. So in the earlier demo, every time Christina ran something, did a Condor submission, if you're doing those through the gateway, then all the steps around those things we call an experiment. So what a gateway can do is capture all those steps that went into submitting and executing and getting the data out of those experiments. So all those things are metadata objects. So basically the gateway can store these metadata objects and provide them back to the user. So the user can search for their experiments. They can look over old experiments, and they can also, so sometimes you may need to go back and see a result that you got last week, for example, or something you did 6 months ago. In a gateway, it's all that metadata is going to be there stored for you. And then the other thing is, of course, you can also clone your previous work. So in our terminology, after an experiment has been launched, it can be canceled, but it's immutable. So you can't change it, but you can make a copy of it, and that copy can then be updated. So if you needed to use a different input file, or you wanted to send to a different resource, or whatever other reason you might need to resubmit something, then you can do that through a copy or a clone operation. So you can build on this idea of experiments and metadata that gets captured in the gateway as people, derives from this sort of guardrail notion that if you're putting certain things available, making them available through the gateway, then you can capture directly what everyone is doing. And so then that metadata then can be archived and can be, as I said previously, you can look for it and review it, maybe make some changes, or at least if you need to get that result again, it's there for you, you know how to find it. But also you can take those objects and change the permissions on them. So I can share now my experiments with other people that I work with using notions of groups and permission settings. So a common example of this would be you have a classroom. If you're a student and you've been working on your assignments and you want to share a bunch of that stuff with the grader after you're done, then this is a way that you can do that. Or if you're a grader, if the student's having trouble, you can share experiments to go in and help the student, or if you're an administrator, help the user figure out what might be going wrong. So this idea of metadata, objects, or groups, and permissions can also be extended to anything in the gateway that the gateway manages. So you can also put permissions on software and resources and data. So I can use groups to say, for example, that everybody might have access to certain software, but a power user group, or a group that might have licensed software, for example, that's in a license group, they're going to have access to not just the software that everyone has, but also their special reserved software. Likewise, I can put these sorts of permissions on resources. So I can, for example, say everybody gets access to the OSPool access, but then only certain people who are in an allocation can get access to an access point that is allocated through access. It's a lot of accesses. But anyway, maybe another way of thinking of it is what we commonly use this for, and what I'll show later is we can have some users who have access to their university resources. So if you're from Indiana University, you get access to IU machines. But then if you're not from IU, there are other machines that you can use. And then next is the ability to integrate multiple types of resources. So the demo I'm going to show is not a built from scratch gateway that is optimized for exposing all the functionality of Condor, HTCondor, but rather it is a general purpose gateway that can submit jobs to OSG access points, to high performance computing resources that might be local to your university or might be one of the national high performance computing allocated resources. And it might also involve some interactive resources, anything else, right? And so the reason for this is I have workflows here in quotes, and that I do not mean Dagman, your Condor person, necessarily, or strictly speaking, I'm not talking about, the scientific software for executing workflows, but the more general notion that a scientist or a scientific research team may need different resources for different jobs or different parts of their overall research. So gateway architectures make all of this possible. But before I go on, let me take a breath and also ask, does anybody have any questions or observations so far? Chat. Any questions? Okay. So how does all this work? At a high level, it's the nature of these systems. So this is an Apache Arbatha specific architecture, but there are other systems, other types of gateway technologies that follow the same approach. So I'm speaking generally here, and I'm narrowing down to specific details of what we do on our team. So basically here, the idea is that there are lots of resources that are out there. OSPool, access allocated supercomputers, other machines that you might want to integrate. And so basically, all of these things can be interacted with through middleware. So in our approach in Apache Arbatha, we use a shared nothing middleware, which means that middleware sits on hosting VMs someplace that, in our case, that we operate, and it can interact with machines at other places. It can interact with HTCondor access points or Expanse at San Diego and so forth. So we don't need anything installed on these remote resources. In practice, most of this means that we have to do SSH really well and really scalably and nicely and play well with these machines. But there are, of course, mostly now from the past, but there are also more programmatic ways of interacting with APIs like Globus and Unicorn and other things like that that have been used in the past for interacting with these machines. So this middleware is a thing that is going to set up and run jobs, help move data or coordinate data. But it's also the thing that is going to manage user accounts. Group account management is functionally in here, and then also metadata capture is in here. So this middleware exposes programming interfaces or APIs that you can use to build lots of different web and other types of user interfaces. So the APIs are accessed by these web environments. We provide a default web environment for people who work with Arbatha, but you can also bring your own. So There are many gateway frameworks available. You can go to the Gateway Community Institute's catalog to see a whole bunch. So if you're a developer and you're thinking about doing this, I urge you to look at your choices and choose one and work with the developer community. If you are looking for help with considering the options that are available to you, the Gateway Institute can help advise you. So we have members from the Institute includes members from multiple different gateway framework communities. And now we're going to look specifically at Apache Arvatha as gateway middleware and front-end tools that are developed by the group at IU. So our approach is, again, building on the couple of slides ago. In just a minute, I'm going to do some demos and get away from the slides. But so we want you to know, when we look at the demos, we're looking at the Arvatha Django portal. And specifically, we're going to look at an instance of it that we put together for the Event Horizon Telescope community for a proof of concept. But this is a full-fledged thing. If you came to us and said, I'd really like a gateway, but I don't have resources to do it, or what should I do? Our first answer would be, we'll make a version of Django for you, or we'll spawn clone a version of Django for you, and then you can configure it, and we can go from there. So the stuff that you see is Django. But you should also understand that a lot of the features are not tightly coupled to the Django framework. So one thing that we're going to spend a lot of time in the demos looking at are things like changing permissions and creating groups and putting people in groups and what groups can do and things like that. So that's a full-fledged standalone service in the stack. It's called Custos, and it's a separate piece of open source software. We can run it for you as a service, or you can also download this and use it yourself. And so this does all of the security service bits that gateways need. So you don't need to, if you have your own way of doing job submission and data transfer and so forth, but you'd like to take advantage of the services that we have for managing federated authentication, user accounts, groups, permissions, and credential secrets, then you can integrate Custos as it is. So we work with the Galaxy team on Custos, and also we work with another group, the HathiTrust Research Center is another example production client that we work with that just use the Custos part of our stack. The other thing that we're going to see a lot of here is the, if you will, the Arvatha core or Arvatha classic services. So these are the things that execute tasks, they execute workflows in that overloaded term. So this is based on an embedded framework that we build on top of called Apache Helix. It came out of LinkedIn. In addition to running those tasks, as I said, this is the part where we capture the metadata. And this is the part where we manage information about what a user did with their experiments and what resources are available, what software is available, those sorts of things. Some of those things may get further pulled apart for the future for maximum composability. Not a big part of the demo here, but I'll say a couple of other things that are in the lab or making their way out of the lab are some data services. So one's a managed file transfer and the other's a a data lake service, so we can use these services to build entirely data-centric gateways that have nothing to do with running Condor jobs and things like that. So that's the stack. It's all open source. It's licensed through the Apache Software Foundation. It's a lot of stuff. And what we generally recommend and what we do for our clients and collaborators is that we run Apache Arvada software. We run it as essentially a cloud service called SciGap for Science Gateway's platform as a service. So if you're interested in following up on the things we're talking about here, again, you can use the SciGap platform and we can create a sample turnkey client for you. So there's no coding here, it's just configuration. And you can also customize the Django-based front end as in a shallow way or as deeply as you want. So you can change the look and feel using a built-in content management system plugins, or you can go all the way down to creating entire Django apps. You can pull away the default interfaces that we provide, but build on top of the programming layer that's built into Django or built in our Arvada Django. So I'm going to switch gears now to look at some demonstrations of how all this works. So one thing to keep in mind is that I'll be doing this as a couple of different users. They're both named Marlon Pierce, but they have different permissions and they do different things. So one is the regular user, and that gateway user can do the things that are described in this document link. So if you're looking at the demo later and you want to play with it later, then this is the place to start. So everything that I'm going to describe here is included in the documentation. The documentation. The documentation is not specific to the EHT. It actually uses a chemistry application, but the ideas are all the same. So that's Marlon number one. And Marlon number two is the administrator. So administrators have additional privileges within the gateway. And we'll see how all those are illustrated, but basically administrators can decide which applications are available. They can decide who has access to those applications. They can help. They can get access to other people's. So this is a privileged user, so they can get access to other people's experiments to help figure out what went wrong, perhaps. Things like that. So that's Marlon number two. And I'm happy to post these links into the.
Yeah, if you're, I think we can go ahead and share the slides now.
Right.
If they're.
Yep. So yeah, Marlon number three, we won't see today, and that's the gateway developer. But that's also if you want to go in deep into how to modify the CMS system for your changing look and feel or anything else, then those documents are here. Okay. All right, so break out of this. And let me put, just for everyone's reference, I can put these in here. Okay. So then thank you, Zoom. So then I have these things up here so you can. I'm not going to speak through the documentation, but I'll try and illustrate all these things. If I forget any steps, I may run back here to make sure. But also, if you again want to play with things later, then you can do that here. We'll give you the user privileges. I think the some of these for the administrator, I'll illustrate. I think some of them are you could potentially mess things up for the HT gateway. So we'll probably not give you that permission, but maybe if you really want to know more, then we can figure something out for you. And then the in-depth information about modifying look and feel and doing deep modifications to the front end are here. I'm going to chat message. Thank you. Okay, great. Okay, so let me pause here again and ask if there are any questions or observations.
I have a quick question about your SciGap, so Science Gateways as a service.
Mhm.
How much in the kind of test instance, is there anything connected behind the scenes, or is it more for kind of testing, like exploring the interface and how the Aravata setup works?
So SciGap is our production environment. So it's basically we have also development environments, of course, internally, and occasionally, somebody who's really on the edge here will also be working with our development stack instead of our production stack. But for the most part, well, for the SciGap stack is, I'm not going to go here in detail, but basically this is the thing that you would go to and apply for a gateway.
Got it.
And Aroma or somebody on the team, usually Aroma will handle that email and will contact you and make sure you're a real person and you're someone we're going to be able to work with. And so, I mean, not passing personal judgments, but like you're not from Prescribed Nation or anything like that.
Yep, that makes sense.
Yeah, so basically a little check and also make sure that you came to the right place. And so then she'll provision a new gateway for you. So which is basically there's a generic gateway. There's a generic gateway called Test Drive, also that you can just try out. So this is all based on the Django portal framework front end, and then the Aravata middleware. So for this little collaboration with the EHT team, we spawned off a new gateway. So it's a new tenant to our middleware. Lots of other tenants connecting to the same middleware, and we skinned up an interface. So made up a nice little quick interface here. So before I even log in, I'll say, all of this stuff is basically a skin that was created for us by a UX contractor we work with, and kind of put all this together pretty quickly in a couple of days, and gave us the skin, and then we converted it to make use of the CMS. So basically, this is a general idea with the gateway is that anything that you can do in the web here, so anything you can do in the web's really good at, giving you text and nice pictures and movies and other things like that. So, this is if you will, an environment for making use of the software and the data that this group is interested in. So I already have an account, And I will, just for tutorial purposes, stop sharing just for a minute. Share again. All right, so there are two ways to log in here. Preferred way is not the way I'm going to do first, unfortunately. But so I created these two accounts. So one is the preferred way here is to use institutional credentials. That's going to use CI logon and some other stuff, which you kind of saw earlier. We'll see it again in a few minutes. But I can also create local accounts, which are sometimes useful. And so I'll sign in, and save. All right, so I'm taken to this dashboard. So some gateways have lots of software, and so this might be filled with cards. Here we have primarily this OSPool application that Christina walked us through earlier. There's also a little test application, which is grayed out. It's grayed out because this was available only for administrators or people in that particular group as we were debugging things. So I can get started. I can go to, I can choose this application. And so I'm going to create an experiment. A lofty name, but basically it means I'm going to set up a job to run someplace. So I need a name. One's been given for me. Here I can change it if I want. I can add a description for my later reference. And I can associate it with projects. I'm going to use the default project. So project is just an organizational concept. And plus some stuff, but basically this is just a way for me to organize and maybe share my work. Okay, so I'm going to need to provide some inputs for running the application. So I'm going to need this HDF5 data file. I can pull this up. It's this one right here. I can pull it up from my local environment, or also I can select it from an online storage location, which in this case are things that I set up previously. So I can go to, let's see here. Yeah. So I can select, the file here. So if you remember also from Christina's walkthrough of OSPool, there are various parameters with inputs you need to provide, like R-high and the data viewing angle and this row knot density normalization. So you can provide those and update those parameters if you want. So default values have been provided. So I want to select allocation. Looks like I only have one OSG path. Cool. And so the only resource available to me under that allocation is the OSPool. Right. Some settings that I'm not going to mess with, and then I'll save and launch. All right, so here's the experiment summary. These are the things that all the metadata associated with the job that I just submitted. Additional metadata will be added to it. So it's now been queued on the Condor access node. So that also, as the job makes progress, or when it's finished, you can also see some of the smaller, you can enable or disable some of the text or image files, the web-friendly files that might be available or created by the output. So not really used here, but if you were running a job where you wanted to look at an output file that was being written as it was being written, like standard out or standard error, you can can grab those. In other scenarios, you can grab that here. So that job's being run. It'll take a few minutes to work its way through Condor as it finds a resource to use. So a couple of other things I can do at this point. I could cancel it if I want. I can clone it, which means I can create a copy of this and submit it with different parameters. And then the last thing I can do here is I can share it. So I can share that experiment with the other me. And I can also share it with a demo group and give them various permissions. So here, read means that other people can see all the, we'll look at this in more detail later. But read means other people will be able to see all the information about the project, and they'll also be able to make their own clones of it. So I'll say that those are all general purpose. All the stuff in that group and permissions schemes are all general purpose and can be used and integrated completely separately from this Django interface that we're looking at here. So anyway, that job is going to run for a while. So I can go back to my dashboard and I can look at a job that ran earlier. Actually, let me look at a different one. Right, so basically here, instead of looking at the as yet unfilled text areas, I can see some of the preliminary values of the parts of the outputs that I've said I wanted that are accessible to me here. So there's the HDF5 generated IPOL plot that was output by the program, by the software, the parameter file used, and standard error and standard output. And then all these files are also here and can be examined or downloaded independently. And I can download the zip of the whole thing as well. And then at the bottom are all the submission metadata and no errors. Great. All right, so that is the dashboard. So if I wanted to look at, so these are my recent experiments, and so this little job is still chugging away. So I can also look at all the experiments that I've run, and also I can see, so I'm, again, this Marlon 1 user, and then there's also another user of the system with a remarkably similar name, but a different person. So when I look at experiments, I see all the experiments that I've run, and then all the experiments that other people have shared with me. So, you know, a lot of these are remarkably similar with each other, but nevertheless, you can imagine building on this where there's lots of different pieces of software and lots of different applications being run and so forth, where you might want to sort through these things. And so you can search for your experiments. You can select the date range. Just give me what's available the last day or so. You can search by various attributes, and you can filter by various statuses that the gateway can have. So give me all the failed jobs. For example, so no failed jobs. Let's see. So make sure I'm remembering everything. So all of these jobs are basically available to be cloned. They can be shared with other users, and I can see what other people have shared with me. So there's also the notion of projects, which are kind of a holder, a top level, if you will, folder for holding lots of different experiments that are grouped together, or that, or you might say, are associated with each other. So it's not much really particularly about a project, except that it can be also shared. So I can create entire projects that will inherit sharing settings. So I can have a test project that's I can share with the let's see, I have the groups that I can share with the tutorial group. Yeah, the demo group already has it. So things that are in the sharing, things that are in the project are automatically going to be shared with individuals or other groups that are in the system. And so I'll cancel. And then next thing is storage. We saw this a little bit earlier, but so this is basically a folder-like structure for you to access your data. So all this data is not sitting on the all this data is not sitting on the access point. It gets pulled off the access point to a location that we specify. In this case, the location is back to the portal server. Pardon me just a minute. All right, so I can also go here and I can see here are all the outputs that have been created. And I can download these individual files. I can remove them if I want. And then I can also download the zip of the entire thing if I want. Okay, so that's all the functionality in Workspace. All right, so any questions so far?
Do experiments have to have unique names?
They'll have unique identifiers.
Okay.
Yes.
There is a system generated unique name tagged with the time, but users have the option of changing the name to anything. But apart from the name, there is a experiment ID, which is a system generated unique ID. So it's either way.
Yeah.
But if you're like me, in my grad school days, and you tend to call a lot of things, junk, then if you call all of your experiments junk 1, junk 2, and so forth, you might not remember what they were. So the experiment name is not a unique identifier. That's a lower level thing, but you can use it to help you quickly find what you're looking for. In addition to other search features, it's really more for the end user, for their convenience.
And Marlon, I also have a question. I think you earlier said that project is a way to organize the experiment so that you can group it together for sharing. So the sharing is at the project level, then not at the experiment level. Is that correct?
So Roma might want to step in and correct me here, but no, you can share at both levels.
Okay.
So you can share everything in a project, or you can share specific experiments.
Okay, thanks.
Yeah, thanks. Thanks for questions.
This looks
Okay.
very nice.
Yeah, if I may just add that to that, I think you can even further, get more granular. You can only share the output files or the input files. So the sharing is a general thing. You could apply to any of the artifacts that what you're saying in the gateway.
So, yeah, and so let me also then build on all this to say that the sharing, all of these services have an API or have API methods associated with them. These are all part of the Custos project. And so we've shown how to implement these things for our specific use cases here, but they could be potentially, or they could be used to support all kinds of other sorts of group and permission type scenarios.
Okay, thanks.
Thank you. Okay. So let's look briefly at groups. So I've created 2 groups. So these are all the groups that are available to me. Or rather, sorry, these are all the groups, and some of them are available to me. So every user is in the gateway users group. Admin users, which we'll see more of in a minute, are in this group. There's another group useful for demonstration called read-only admins, so you can see everything an admin can see, but you don't get to change anything. Then I created a tutorial group, a demo group, and the other Marlon created an example group. So then I can edit these things in this group, it's only me, but I can add Marlon number 2, and I can add so later on, if I navigate through everything correctly, you'll see, or you can see how Marlon number 2 has access to things that are in the test group. So I can create a new group if I want. And basically any place where you see the share, where you see the little share button or action, that's the thing that you can share with individuals or with these groups. So then the example group is owned by, if I didn't say this already, it's owned by Marlon number 2, and that example group is another group that I could potentially be a member of. All right. So again, there's a lot of things here that are implemented in specific ways for these within Django, but there's a tremendous amount of flexibility within the group and user and permissions management schemes to build entirely different types of web applications, web things. Yeah, can you request group membership? Roma, you want to tackle that one?
I'm looking. Yes, so not just the group membership. So the users are able to see what groups are available. And in gateways, the groups are created in a sort of a meaningful way, especially in production gateways. And they can request membership, and also in gateways where there are multiple applications, users would be able to see what's available. They may not have access. So they can, by contacting the gateway PI, they can request access to applications, resource, check what's available. They can work with the gateway PI. Yes. Stephen, did I answer your question? Thanks.
Okay. All right. So then the last thing I wanted to show here was settings. So there are a couple of other things that you can potentially do here as a regular user. You can potentially connect your own resources. So there's some plumbing that still needs to happen. So this is, if you're using SSH keys, then you'll still need to deploy the key on the target resource and have that resource added to the pool that we have available. So there's still some manual steps in there, but you can also, as a regular user, potentially provide your own resources that are only available to you, or maybe only available to a particular group. So again, This is a key I generated. It's just SSH key. You can also potentially share this with the demo group, for example, or not. And then the other thing is the group resource profiles. So I have, as regular old user Marlon, I have access to the OSG path pool, which I can view some information on. So for example, I can view various informations that we use for the deployment, for the integration with the access point. So what login user is there, what credentials are used, so all these are read-only. So I am in this, the permissions I have here are read-only. Some default settings, reservations are, for tutorials when you have a reservation someplace. So I can also, I could also potentially add a resource. So I can use my pets, and then the pets would be selected from this drop-down list of available resources. So I can choose an IU machine. I'm not going to go through all the steps of doing this, but you can configure, or rather, there's some manual steps to add to completely integrate the new resource, but you can do all those things through this interface. And so all these, this queue information is inherited from a general description of that resource. If you have a new machine that you want to add, it's actually, this is done through the SIGAP portal interface, not through this interface. But all that stuff is basically stored in our system and can be pulled up here. So I can save all that. And so I can save it. Let's see. So if I look at this, I've shared it. So the admin users, if they need to, they can get in. If I've done something a little screwy or maybe something I shouldn't have done, admin users can still access that group. But I can also share my pet resources with thoughts on two-factor authentication. Two-factor authentication is a wonderful thing. Two-factor authentication and one-time passwords are not the same thing. So to me, the password is one type of authentication, and possession of a key or a passphrase associated with a key, those, let's see, 1, 2. That seems like it ought to be 2. Yeah, so typically with working with systems that require two-factor authentication, for now we usually work with the system administrators or cybersecurity people on that team to be added to an access list. And we're saying the gateway is going to come from this IP and IP address, and so you'll know who's using it from this particular location. So we also enforce two-factor authentication, or can provide two-factor authentication at the web level. So yeah, there's a whole mess of other stuff about SSH and two-factor authentication that I think I would defer to the bonus round. Yeah, no magic solutions. I know someday there'll be magic. Yeah, I think
I was gonna say, so the access point, same thing, accessing different resources. I think they have run into the same issues.
Yeah, so
Similar solutions.
yeah, so there's the Sci Tokens project that Condor is part of. that might provide some tools here, but that's a little, last time I saw it was a little also command line centric. Or rather, I mean, I would say not command line centric. You kind of had to, it was interactive, which was not a good model for a gateway. But so we could potentially also store OAuth 2 access tokens, you know, if there were no OAuth, if there was no OAuth 2 SSH solution out there that everybody was using and widely supported, then we could, you know, we could do that potentially as well. All right, other questions so far? Chat. You didn't have to ask. You didn't have to ask. No, thank you, Steve, for the questions. All right, so let me move Zoom stuff out of the way here. So that's all for regular Marlon. And now let's sign in with my university credentials. So this is going to go through CI logon. And I'll use my IU credentials. So I already did this earlier today. I forgot to, I guess I could have used private browser or something, but basically I would have been at this step, if I didn't have an active session, I would have been taken to IU's two-factor authentication and I would have duo authenticated. And so you can use you could use potentially other identity providers as well. All right, so now so now I'm logged in as Marlon. I see some of the same things. This OSG test application is now accessible to me. It doesn't really do much, but so basically there were permissions set on this through our whole permission system that I have demoed that said I was not allowed to get access to this machine as a regular, or this application as a regular user, but now I can. So I think everything here I've already more or less gone through so far. So one thing of interest is that I can also, so here I'm a power user, and so we can use the group feature to create more intermediate users. But so this is a full-fledged administrator, so I get access to everything, so I can see what Christina's been up to, for example. I can also so I can see her experiment. I can also clone my own version of it, and other types of operations. So I can also search by, are there any failed experiments? Yeah, a few failed experiments. So I can go here and look at this one. There's a better way to look at this later, but I can see somebody had a failed experiment, and I can do some superficial quick looking at some of the values they used and maybe what happened. And then I can also try cloning it and resubmitting it to test to see if it's still going to fail. All right. Again, projects are here. Same thing as before. Excuse me, and storage is here, same thing as before. All right, so I'm the regular user, but also I can do other things. Like with groups, I think we've pretty much seen groups. But the real fun comes under settings. So if that wasn't too quick, you see a whole brand new set of icons on the left side ribbon here. So this looks the same as before, but it's actually a completely different thing. So this is, instead of the applications, it's the tools that are available to me, it's the application catalog. So I can actually go here and see how the iPool application was actually deployed and made available through the gateway. And I can use the same interface to add new applications. Right, so the details are kind of top level and not that interesting. I mean, they're human readable information. So in our Arvata approach, which Suresh pioneered here, the interface and deployments are two things we keep separate. So the interface is basically what it takes to run the application, and the deployments are what it takes to run an application on a specific target resource. So usually what that means is the interface is basically, if you're talking a piece of software on Unix, the interface is the command line that you need to create. And the deployment is going to be the stuff around the command line that you're going to need when you submit an HTCondor batch job or a Slurm job or any other type of job. So the interface is basically a way to, this part here is a way to essentially construct command lines. So each command line has an executable, and then they're also going to be, for that executable, there are going to be various inputs and outputs that you need. Some are required and some are not. And I'm going to scroll through this. So not only do we specify the command line inputs, or all sometimes implicit inputs that are required by an application, but also we can specify the outputs. So those are all the inputs. So and I can add more if I wanted to, more output or more inputs. Right. So the outputs are all the output files, some of which need to be specified on the command line, some of which are not. One interesting little thing here is also you can customize these things pretty extensively. That's described in the developer documentation. I'm not going to go through that in detail, but so this metadata here is a way of making customization. So if you remember, this iPool plot.png file actually got displayed. Let's see. Yeah, so this little plot file actually got displayed. So this is how you this is the quick low code version of how you modify the input. This input description area to specify that here's the MIME type for that particular output file. And likewise, here's how you can specify if you want to show a file, then you can add this metadata to it to say it's in this case, a text/plain file. Right, so basically that's, and you can add more output files or more output types as one. So basically that's the idea of the interface. And then the deployments. So each resource where this code is deployed or is described here. We have 3 different places where the job could run. One is a virtual cluster on Jetstream 2. The second is the Xbant supercomputer at San Diego, and the third is the OSPool. And so I could potentially add another output. So one of those outputs is available to me because I'm part of a group that included Marlon's pet machines, which is Big Red 3. So I'm a super user here, so I got super user privileges there to Marlon's pet machines. But if I was more of a regular user, I might not have that access, or I wouldn't have that access. So Those are deployments. I'll cancel out of this. I can add a new application. And if you look at the tutorial, you can see how to add. And that would be admin documentation. You can go through all these interface. You can go through all of these things in quite a lot of detail. Let me get back out of here. So I can deploy a new application here. So there's still some manual steps here after I fill out all the forms of actually, maybe I need to get the code actually deployed on the target resource. So there's a step in there that is not automated through this interface. All right, so that's the catalog. Again, I'm a power user. I can add, or I can manage users and their various corner cases and other things that we've seen over the last several years about what happens when users create accounts and there are various account services that I won't go into here where we can set up things like you have to verify your account or your account needs to actually be approved by the gateway owner before it becomes before it's enabled and things like that. So if somebody, for example, if the verification email got lost in junk, then the administrator can go here and just manually enable that account. And then you can also add additional fields to the user profile, so users can be, so if you want to collect additional information about the user, like tell me what your research area is, or tell me, basically any type of information that you might need to see before you, when the user fills out a new user account request. Any type of information, you can customize that in this place. So that's manage users. Quickly, I can look at. I can look and see what Christina's information is. She has not yet provided a favorite color. And we can do other types of operations on that account. All right, experimental statistics. So we can look here. This is a little interface for helping debug some of the problems that can occur. So let's take a look at jobs over last week. Oh, there was that one that failed. So I can go here and say, okay, this one failed. Let me get more information about it. In this case, the error is not particularly wonderful to look at, but if you're debugging this if you're the gateway administrator, you're debugging this. What happened in this particular case was the access point VM was down. If you've looked at enough Java stack traces, you can usually figure out what something is. But also other cases, there'll be other more user-friendly errors that you might get here. All right, and go back to the statistics. Let's see, let's look at completed jobs. And so sometimes it's also useful to look at things that actually were executed successfully. And so in this case, we actually can look at the HTCondor submission script that was generated by the middleware. And also you kind of get a picture of what's going on under the scenes here a little bit. That Arvata has various steps that it takes in running a job that are called tasks. So that the first is environmental setup, and so all these things are customizable through the interface. So environmental setup is if you need to. I'll say more about that in a minute. So there's also potentially data staging and job submission steps, and then also a monitoring phase while the job's being run, and then the staging steps for getting the data off of the machine. Okay. The next is the credential store. I've been playing around with this a lot. So we saw this earlier as a regular user. As a admin user, I can create a new gateway SSH credential as opposed to my own, as opposed to a more private credential. So this is the default key. The thing called second gateway credential here is when you create one of these, it's automatically shared with the admin user group. Whereas if I created a personal key, it's not shared with anyone. So you can associate, if you want to, you can associate these keys with different computing resources. I think that's all for credential store. Group resource profile. So I can look at let's start with OSG path. We saw this a little bit earlier in read-only mode for the regular user. But now in this, I actually have full privileges to change any of these values. So this is why the admin read-only interface is useful if you're wanting to explore things. You can see but not change. So I could add another compute resource to this. This name is called OSG path pool. It's not specifically bound in any way here. That's just a string. I could call it, the junk pool, and then add OSG pool to it, and then add any other resource that's available to me here. And so also I can control sharing with this, so I can create group resources that are associated with specific groups that only certain people can have access to, like the pet resources. Yeah, so you see here, the pet resources I have, I can only view them. That was created by the other Marlon. So these others that I have added access to were all created by the current user, or at least the current user has full permissions on them. The resource profile here, all I'm able to do is add additional storage locations. So this is the place where I could send the data when I get it off of the access point. There's also there's a tool for posting notices if you're an administrator. And then if you want to, finally, if you want to create your own local version of the Django portal for your development purposes. So if you're developing your own gateway, and whether you're an EHT developer and you're going to be making extensions to the gateway in your local dev environment, and then you want to get that set up, then there's a file here, settings local py file that you can download for that to get that set up. So There are various other scenarios we could go through here. For example, playing around with adding additional applications, or dummy applications, or adding additional resources. Using groups to see if I can create my own private pool of resources and share them only with a couple of other people, or share them appropriately with a group. Those are all the capabilities that are in the interface for the administrators. But also regular users can also take existing deployed applications and add their own resources. Okay, I think I've gone through everything. Are there any questions? I think I had a couple of slides to go back to for wrap up, but before I go, any questions or comments from anyone?
It looks very nice.
Well, thank you, Mona. Okay. So I will go back here. So again, documentation, you want to play around with these things later. This is what the regular user can do is pretty much all described here. What the admin user can do is pretty much all described here. So we have a couple of options if you really want to dive in. One is to make you a read-only admin, where you can see everything, but you can't make changes. And the other option, if you're really wanting to take a deep dive, is we can create an entire playground for you. And so for that, you can use the interface to do all of these steps. And then last thing is, if you're wanting to do a lot of deep customization, change the look and feel, get rid of the HT stuff and put in your own project information, how do you do that with the Wagtail CMS? How do you make deep customizations to the Django interface? It's all described here. All right. Okay, I think that's it for me. So Christina, you wanna take over?
Sure.
Let me stop sharing.
Okay. So everyone still see the slides? Yes. Okay, great. So now we've made it through our list of topics. It's been a long journey, but this is why we shared the slides in the chat. We'll also make sure that you can get a copy of those via email, or they're posted somewhere. And then the recording will be on YouTube, I believe, on the Gateways channel. So some next steps, after hearing all this information, if you are keen on exploring the Open Science Pool, all of the features that are available on an access point, the different OSG services, you can apply for an account on an OSG Connect access point. Again, no allocation needed, just you apply. Similar to what Marlon described when you apply for a gateway, we also have a quick meeting with you to confirm that you're a human and not a robot, and get you access and give a little orientation. I mean, you could also tool around a little bit on the notebook site that I shared earlier, but that's not a full featured access point with access to the Open Science Pool. It really is just like a little HTCondor test sandbox. So if you want to explore more of the features, it's worth applying for the actual OSG Connect account. Yeah, and then I think Marlon has referred a couple times to different options for exploring gateway tools and technologies that you can get kind of a clone of a gateway on their SciGap setup. You can set up and explore, that you can maybe become a read-only admin on the existing EHT gateway he was just showing. So lots of options for exploring gateways. And then just in general, there were all the links that were in the slides that Marlon just showed. We've got the OSG Connect docs, the email address to contact us, Gateways group contact, user docs. So there's plenty online. Hopefully these emails are ways to reach us. I'll also put my personal email in the chat before we leave. So if people want to reach out, they can. And that's it. So Marlon, I'll let you answer the question in the chat.
Yeah, I'll kick it over to Aroma or Suresh if they know the version of Django.
Hi, Mona. Are you asking, is the gateway portal you saw has the latest what we have in production?
I think production is my question. Are they running different versions?
Okay, so the EHT portal that Marlon was demoing, it's in it's a production portal. So it has latest everything that we have released for production. But as anything like we do have monthly updates, it could be issues, it could be new features. So there is a little bit different things happening in the development, but they are as planned, they get into regular cycles and get released. So when we released, what we do is we have so once we do the release into production, we inform all the gateway PIs and we share if any of those releases needed to have documentation so they could use the features, we add them to those documentations of the admin users and generic users that Marlon was showing, and we share that and tell them. So it's a monthly thing. We send this email saying, okay, we released, these are the things fixed, these are the Git issues, and for you to use these are the features. So there is a slight difference between the active development stack and the production, but it's because of the current things that we work on.
Okay, thanks. And they're both using the current version of Django?
Yeah, so Mona, I think looks like you're asking more on the Django. So we haven't yet upgraded to the Django 4 stack yet. We are in the long-term release path on the 3.2 stack.
Okay, thanks.
Yeah, and we don't have a plan yet for the 4, but Marcus has looked at it a few times and observed some things but we never made a plan for when we want to do that.
Okay, thanks. Yeah, it's always kind of challenging to stay abreast of the platform.
Yeah, so I think that's the thing. What we need to think through is not just the core framework, but the community has developed apps around them.
Right.
So we need to come up with a way on to figuring out if any of those apps will break and all. So we did run into two of those issues. Some of the apps getting developed on a different framework, and they would like to put different version of the framework they would like to bring in. So we did space with them, and we try to resolve them I don't know, ad hoc basis, but we need to come up with a structured way. So far we didn't run into that too much, but we need to think about this major jump with Django 4 and so on.
Okay, thanks.
Yeah, I think thankfully the Python issues are not everyone is on Python 3, so that's one less of a headache. Yeah.
Great. Thanks, Suresh. Okay, so there's some potential starting points or resources for everybody. I wanted to close with these 2 questions as feedback for, I think, especially for the presenters, as we kind of represent these tools and finding audiences that might benefit from them. So if we had a gateway with a, OSPool as a computational backend, what kinds of gateways for what communities could benefit from the Open Science Pool or those services? And who else? Kind of a similar question. Who should we share this tutorial with? There are people not here today, but who might benefit from learning more about these tools and stacks. So this is more just me being like, who could we be reaching so that people adopt these tools? If you have ideas, feel free to chime in or drop some ideas in the chat. But I'll just leave that open, and that's the end of our content. So thank you all for attending, sticking with us through this tutorial.